Welcome to the March meeting of the BBAA Amateur Astronomers. First up, we got our Vice President, George.
I got 4 things, real quick. I put all the calendar events for the next 2 months up in the board, so you want to copy them down, I don't have to say anything.
He copied them twice, too, today.
I got 3 awards to give for last year's outreach. Mel Sproul.
Yay!
There you go! Woo! Bird Taylor.
Oh, thank you. I just love working it out. Hey, thanks, guys. I couldn't have done it without you.
And Bob Berline.
Yay!
Also, we received a certificate of appreciation from NASA, JPL, Night Sky Network, and the Association or Astronomical Society of the Pacific. NASA Night Sky Notes Appreciation 2019. NASA Night Sky Network recognizes Back Bay amateur astronomers for your use of the Night Sky Notes monthly article in 2019 and the valuable contributions to your community in the areas of science, education, and inspiration.
Well, they got all that on smart.
Boy, we fooled them. Give it to Joel. Give it to the president. The last thing I have, I got my reflector in the mail, and I always look at the back of the reflector to see who got the awards. And it used to be, up until a few months ago, or maybe a year ago, always there'd be somebody from the Back Bay amateur astronomers in the list. Well, in the last couple months, last couple quarters, have not been any from the BBAA. However, we've got 3 this time. Transit of Mercury Special Observing Award, Bob Berline. Bird Taylor. And Jeff Goldstein, it says member at large. It doesn't have BBAA.
What?
Very large.
Must be some mistake.
Anyway,
Typo.
let me encourage you to go to the Astronomical League, figure out a program that you want to do, and get your name in the reflector. That's it.
Hey, George, I'll add on to that. I didn't catch it at pre-time, but I did just that. And they have a variable star one, I found out.
Wonderful.
And I went to submitted all my, because I had earned it 20, 30 something times over. So I just sent them in and they're like, oh, there you go. Certificate, pen.
Well, check.
Woo!
But it's number 36, so I guess not a lot of people have done this, but I was going to bring it up. If anyone wants to do it, it's not very onerous. You only need to do 100 observations on 15 different stars.
Only?
But variable, how many observations?
100. Now, I do
That's a
almost
lot.
15. I've done almost 100 in a night. So
Was that with or without vodka?
it's with hot chocolate.
Oh, Bob brings hot chocolate.
But if anybody wants to do it, just let me know. And I'll
That's right.
Oh, that's
Wonderful. And you can pick the 15?
yes, you can pick the.
Can't talk to
15.
Randy
One
now.
of the requirements was to follow Myra through one cycle. So that
What's the period?
Randy.
usually
Randy
most
who?
Myras run 300 days. Some are as short as 2 months.
So find a short one.
So find a shorter one. Some of them have 1,000-year or day periods.
Cool.
But
Good job.
See volleyball sign
Have
down
you
there.
ever presented on the curves? Have you?
Did
Did the hippie sign in?
yeah, I put them up there.
That's really fascinating.
Melvin did sign in.
They had the.
Oh, yeah, there it is.
so
Never mind.
website has some pretty good tools.
We're going to try to move along so we can get to the presentation.
All right, next is our secretary report, and Kayla is in class right now. She was almost tempted to skip it, she told me, for this presentation, but she decided to go to school.
I make a motion, we don't read the minutes.
I second.
All those in favor? Aye.
Nay.
And just so you guys know, I did, she sent me the January, February, meeting minutes, and they are on the website if you want to see it. Next up is the treasury report. Chuck?
We got money.
Good.
We got $6,300 in the general fund, $1,189 in the primary scholarship, and $1,604 in the Georgia June.
Wonderful.
Excellent.
We got
No
an
more dues
extra-
required. Excellent.
Yeah. So that gives us about a little bit more than $9,000, $9,118 in the whole kitty. We got 119 members, 97 regular, 15 associates, 5 honorary, and 2 associates that don't pay anything.
How many are regulars?
On all of us. And that's all I have for the treasury report. Ben has suggested that maybe we ought to bump the Georgia June scholarship from 500 to 1,000. I think it's a pretty good idea. But he's a scholarship guy, so he gets to figure that out. The other thing that the treasurer has is we wanted to order do an order for the Cavalier Sportswear tomorrow. Minimum order for t-shirts is 25. I currently have an order for 10. So either we hope that somebody's gonna order some more real quick today,
Is there one t-shirt in this room?
or the club pays for 15 of them and hopes that they sell them over the course of the next year or so. So 15 times 12 is how much, math majors?
A lot.
It's over 100.
It's,
180, 145 bucks, something like that. 170.
180.
180 bucks.
You
Somebody
know,
will have to be the keeper of
your
them.
phone out.
Somebody would have to come up with, they think, what the good colors are and something what people might want. And, something we can discuss maybe, but that's, otherwise I'm gonna have to return 10 people's worth of money.
Come on in, have a seat.
So, we can discuss
So
it.
this is the discussion order.
Okay, I mean,
3 more t-shirts.
oh, I got 2 more rewards. Got 2 more rewards.
Haley.
They just arrived.
Chuck, I'm not.
Okay, this is Lifestyle Network
Network.
Network Star Award.
Well, no, then you can't.
Don't get too comfortable. He's talking about.
Jeff Thornton. Jeff Thornton, you got him. 2019.
But it's kind of like the one I've already got.
Yeah, you got, that was for the last year, or the previous year.
Tell us
And
about that.
look,
Okay.
Chad and Caitlin, home. There you go.
What do you gotta do for each one of those, please?
You want to
There we go. All we need is 2 officers to agree to do it.
Tell people.
Do you agree?
I agree.
I agree.
And we'll make George pick
Let's
the
make it
colors.
happen.
Okay.
So we're gonna order the extra shirts, and I'm sure that we'll be able to sell them probably on the boardwalk, actually. That's what most people
The
discover
t-shirts
they
are
want.
12 bucks a piece. Just give me your size and the color you want.
Let's see, if any of you guys change your mind, this is the shirt, this is a wicking t-shirt. It works real well down on the boardwalk, you see all the different colors they have.
That's what we're getting.
And there's also a women's version of the shirt too.
What color is the printing?
I don't have to tell you.
White.
Well, I guess
Or
unless
white.
the shirt's black. I
Or
have a
white.
dark gray one and it's white for printing.
I'll be right back.
I don't think they vary other than black and white out on printing. But if you do want, Chuck has, he just left before he can verify, but he has that square, so he should be able to take your money right now. You can go on the website later. We're gonna order them no matter what, but this way you can make sure you get your size. Because there's many options.
It's really good price, actually.
This is a lot better than the first time, but you see they come in a lot of different sizes. We'll probably get some
Two
somewhere
X.
around
Two
this
X.
area here. Maybe a couple of mediums.
We're a big club, big club.
Here's a t-shirt, everybody wants to look at it, this is the material.
Everybody wants to see it. That's the good stuff.
Yeah, they're really good quality and they hold up really well.
How you checked off pay?
Thanks, bud.
Bringing astronomy to the people of Hampton Roads. Oh, very nice. Very nice.
Alright, so moving on then, we got the scholarship report from Ben.
Scholarships out. I think we're gonna wait to see once the funds settle down here right in May. We usually donate the check around June, July. So we'll up the Georgie June then, since the application was mailed out and sent out already and posted. So it'll be a nice little surprise for the second runner-up. But it's amazing that our club size could potentially give $2,500 worth of scholarships, which is absolutely amazing. I'm part of engineering associations that don't give that kind of money out. So bravo to the organization and all the wonderful outreach we do and the recognition. It's really amazing and humbling that we were able to support the youth going off to college with that kind of money. It's pretty impressive.
Thank you, Ben. Alcor report, I haven't seen Bruce, is that here, right? Well, you just basically did.
I just resubmitted the Alcor, list so that anybody who has gotten dink or something didn't get their reflector or got 3 of them,
I fixed the list and sent it in.
I saw that. Thank you, Chuck, for taking care of that. And moving on, we got the triple RT report.
I sent a request email to Ed Murphy Monday and have had no response. So, no idea. How about you, Ben? You been doing anything?
Campaigning.
For Ed? That's so
That's so nice of you.
Hey, VIP wallops next week.
There you go.
So the email was about the status of it?
Yeah, I asked him for a
Okay.
status and I didn't get any response.
Alright,
I'll keep doing it Monday on Mondays till we get it.
thanks, Bert.
Sorry.
That's fine. Okay, moving on to old business. We got the t-shirt order we just took care of. We also discussed, the prizes to use for the Georgia June raffle. And I put a poll up on the Groups.io website. And so far we've only had like, less than 10 people vote. And, which is fine. We're gonna pick something and it's gonna be out these 10 people, so if you guys are okay with that. Or you go on there and vote what you want, or put down a suggestion, and I'll add it to the poll. But right now, Pintex eyepiece is winning.
Oh, that's
Yeah.
an awesome eyepiece.
It's a good one.
That's expensive.
Yeah, well, it's $299 is what it says, which isn't too bad. And
It's a Hummer.
we had a couple of votes for Teleview eyepiece and another Dodd, an Orion Dodd, and one more vote for a planetarium micro guide eyepiece.
That's outstanding.
What is that?
Oh, probably the Vader planetarium.
Yeah, the Vader
It's
one.
an illuminated one, it has the etchings in it.
Yeah, it says with illuminator, and that one's $279. But like I said, I mean, whatever you guys wanna vote on, let us know, because we're gonna go with the one that's got the most votes.
You picking one?
Yeah. What kind of money you think we're made of? We're giving it all away in scholarships. And, let's see, that's all the, old business. Anyone got anything else I forgot? Alright, new business. Anybody got new business? I got new business.
Fine.
One, I forgot to bring it up when we were having our officer meeting, was the wine thing. The winer,
Yeah,
Wine tasting?
it's the spring star talk
Okay.
on the 3rd of April in, at Sade Winery, Lenexa, Virginia, northwest of Williamsburg. It's a pretty dark area.
yeah, it looks like it's gonna be a good spot.
And I got, email back today.
Just about everything.
We're gonna do a star talk, and we're gonna be able to set up telescopes for the people, and then people are gonna leave, and we're allowed to stay at least another half hour afterward if we wanna do any serious observing of our own. And she's gonna talk to people at the winery, and she'll talk, see if they would be able to give a donation to the club.
That's what I wanna make sure.
Right.
Liquor or cash?
We'll get these on order, we're gonna order them tomorrow.
Put it back in the order. Case joint, I'll buy a case.
I mean, we're talking about, we're not public, it's a private business. You know, they could probably do like, you know, make sure that they know it's for.
It's a nonprofit, absolutely, I'll write that.
You know, write that off.
Absolutely.
Well, I thought the email actually said. that
They were nonprofit.
They asked if we were all
501c3.
21 because they wanted to pay us a wine is what it sounded like.
No, don't pay the wine.
It's like, I have to drive 2 hours after this event, I'm not going to drink your wine, thank you, but.
Yeah.
I like the wine.
I'll convert your Williamsburg wine into cash, so someone will take wine too.
But I mean, for this type of organization, we would like a donation. I forgot to bring it up while we were having our meeting. I just wanna make sure.
I seen your email.
I'm assuming agree with that, that's.
we're on top of it.
I seen your email, the way you did it, and it was very well done. I would've just said, give us money. But he was very tactful.
No, that was mine.
Oh, was that yours?
Yeah.
Oh, sorry. Good job, George.
In whatever currency you take for your wine.
And, let's see, other club business is, this is the last scheduled presentation we have right now for the year. So if anyone has any other ideas, and we haven't done a planetarium show yet this year, we can do that obviously.
Before Kenny leaves.
Yeah, before Kenny leaves.
Is he retiring?
It's in the summer.
Okay.
But I'm just saying, if you guys have any ideas, like Jeff thought of this ideas tonight, let me know, we'll put it on the schedule. Otherwise, I'm gonna have to keep
Maybe I said, I can talk about more
We're
stuff,
gonna talk
but
about
you go with the
Beetlejuice
wheel
till
so
your
many
eyes
times. You tired of me.
I've got a couple ideas I'll give you later.
Okay. Yeah, any ideas you guys got, let me know. I don't wanna pester everybody who comes from, like last year that we had come from not an organization, and be like, hey, you ready to come down for your yearly thing? I don't know what their schedule's like. And the last one is club involvement. You got these events here, and George got sick for like 2 weeks, was taken out. Fortunately,
Coronavirus.
we didn't have any events going on really that time period. But it could have been like a major part of the club, yeah, wasn't able to go to these events. So if you guys have time to do the events, and it's not just the events though, if you guys can help out, like Chuck's doing this t-shirt thing, and really we were trying to get someone to do like a store thing. It's like once a year you don't even collect the money, they send it to PayPal. You just are tracking who wants a t-shirt. And when they order it on the website, you have all the information right there. You're just like the point man or woman for it. But when these events come or opportunities come up to volunteer, please don't hesitate to do it because Chuck's leaving. You know, he's retiring, he's going to Colorado, that's happening. Fortunately, Ruth said you might be interested in doing the treasurer part until Chuck talked him out of it.
Yeah, he's hard to
Me.
But I'm just saying, don't be scared to do it. Really, there's not that much to the position I'm doing. There's not really a lot to it. The VP, the treasurer's the hardest one because you gotta work with the numbers. But most of them aren't that hard. My phone actually records everything we're saying, and then I send it to Kayla, and she just makes sure it makes sense, and then gives me the minutes. You know, it's pretty easy stuff. So we'd appreciate that, especially for the outreach stuff though, because we do a lot of events, a lot. And
you don't have to be a rocket scientist to go do the outreach. I'm proof of that.
Hey,
no, you don't have to.
I resent that.
If you guys if you're nervous about talking to people, send it near George. Okay, because he's usually gonna be there, and just tell him, I don't know this guy right here. Because that's what I did like the first year I was in the club.
Look at you now.
You guys suck.
Now he sets up his bar for
All right.
He's quick learner.
If there's no more new business, we're gonna move on.
Question back row.
Stone River Star Party, the 23rd to the 29th this month. Registration needs to be done before the 15th of March. If you've ever been there, it's a great dark sky, international dark sky park, just past, I always say it's past Lake Gaston over there by South Boston. It's not up there by Staunton, Virginia. It's a fun time, good eats. Restaurant, I think, is open almost all night. They have astronomical food, really. Look at their menu.
Can I bring Stewie?
Yeah. But no green lasers, and outreach night is Friday night this year, I think.
You said no green lasers?
No green
Why
lasers.
not? How come they don't do that?
Photography.
Huh?
Oh, because of photography.
Mm-hmm.
I see.
And they do have an RV park across the street, so you can park your RV if you have one, or take it into the field. I have a pop-up, I'm parking it in the field. They have electricity in the field for astronomy gear and charging your batteries, not for, running your,
Wait a minute, ran mine.
and not for running your air conditioner or stuff like that, but it will run minor stuff.
All right.
Good, thanks.
Anybody have any other new business? All right, moving on to observing reports. Anybody got any observing reports? Nothing.
Jupiter, Saturn, and Mars in the mornings.
This is not an observing report, but Arch and I conducted a 4-week astronomy enrichment class, one Tuesday afternoon a week at Ocean Lakes Elementary School. And we had some really interested kids, and it was good, wasn't it, Arch?
I enjoyed it. I hope they did.
I did see that on the schedule. I'm glad you guys did that.
Thank you.
Fortunately, it worked out okay because
He was sick as a dog.
I was sick, but he helped me a lot. He just really filled in for me.
Thank you.
Yeah, I looked at the Leo shipment. I got it. Image. Worked
very cool.
There's a SpaceX launch out of the Cape tomorrow night, and it's going out to the International Space Station. And that means it's gonna be going up the East Coast at about 11:50, right before midnight tomorrow night.
Is that before or after the storms?
Well, it's supposed to be clear tomorrow night. It's raining tonight, but we've seen some Cape launches before from Norfolk when they go out to the IS.
Oh, yeah, yeah.
So
Yeah, we've
it's,
seen
we
several.
saw Starliner in December when it came up, and we saw one of the Starlink launches. So there's a possibility toward midnight tomorrow night. You might see.
One of the best ones I saw, did like you were talking about, went down the East Coast. It was during sunset, I think, time frame, but this will be.
It's gonna be well after dusk, but if they do staging and they come up, it might still see it.
Very good.
One in my program is a star CQ Tau for Tori. It's a T-Tauri star, which T-Tauri stars usually have dips because the dust and their protoplanetary disk, but this one's actually had a couple flares recently. It's usually like in the 10th, 11th to 12th magnitude range. I caught it twice last week, up almost at 10th magnitude. It's like 10.2, 10.3. Some other guys in Britain saw it flash too, so I wasn't crazy. Somebody else saw it, but that's very unusual for a T-Tauri star. So we don't know why.
Oh, yeah. You guys have a hypothesis why?
I don't. Somebody probably does.
Probably a planet.
I'll give them the data. They will figure it out.
You have anything we haven't heard about Beetlejuice? It's
It's
obviously getting brighter.
It's
right?
going back up.
Okay. So it's not gonna blow up.
It will.
Again, yeah, but like you said, the outer layers, all the dimming is what's going on in the outer layers, has nothing to do with the inner core of the star or collapse. So there's no relation to dimming. The people that are the journal articles I've read, those guys seem sure. I'm just repeating what other people with PhDs say.
I did see also Orion, of course, I was at the planetarium. Been there a few times over I usually go there like 2-3 times a month to help out with Ken. But we saw the trapezium real well. Saw the 5th and 6th star last week when we were out there. 14? Yeah, in the 14th.
I've never seen that.
Actually, we was an event that I would have my telescope. It just happened when I was somewhere earlier that week, and I left it in the car, so I took it out at the planetarium. I think it was 2 weeks ago, and you could see the 6th star in my 10-inch. Wow! So it was really good. But that's all I got, Jay. It's been pretty nasty out there, it seems.
Saturday.
Yeah, we were out Saturday night at the Gap. Marcos was finding all sorts of stuff. I was just doing naked out of stuff.
No mosquitoes right now, though, right?
Zero. Awesome. So you gotta take advantage of that out there.
Yeah, that window's
It is
closing.
not the same in the summer. It's not in the summer. It's brutal.
All right, Jeff, do you need
Okay.
do something? The video hasn't come back now for like
Oh.
4 or 5 minutes.
Okay, well, Lee, turn on the video. I'll introduce you while you're doing that. And I'll put his name and everything.
As I said, we're ready to roll into it.
We're rolling into our speaker presentation. I'm trying to shoot the video, and there he is. Our guest speaker tonight is Mr. Leigh Torgerson from Jet Propulsion Laboratory, live from Pasadena. And he's laughing. We talk live occasionally on the telephone, of course, but lately we've been doing it live through this WebEx. So he's got lots of cool things to say, and I'll shut the heck up and let him talk. And there's his his email address, torg@jpl.nasa.gov. He's got lots of incredible things to tell you, and I won't spoil his fun. Go ahead, take it away, Lee.
Okay, thank you, Jeff. Can everybody hear me okay?
Yep.
Yes.
Unfortunately, what we learned experimenting with WebEx, which is kind of the coin of the realm for NASA these days, for the endless meetings and the endless PowerPoint presentations. Works fine for PowerPoint, but it sure doesn't work very well for videos. So I had some videos to show, but I'll be able to show one short one anyway, and it'll be a little choppy, and apparently Cisco hasn't figured out how to do streaming video in their WebEx program. So apologies in advance.
Switch to Zoom.
The next thing I'll do is I'm gonna go ahead and go through a quick history of what we've done at JPL, and you can stop me if you have questions, and then some more detail about the last moments of the Cassini mission, and then the exciting thing for the future, besides the Curiosity rover's up there now, and they're launching this summer. They're launching Persistence, I think they're calling it. Some junior high school kid from somewhere in Virginia got the name the next Mars rover. It was just announced today. After that, we're looking at exploring some of the icy moons and water worlds in our solar system. I'll tell you a little bit about that at the end. So without further delay, I'm going to go ahead and try to share the PowerPoint slides. Okay.
Terrible.
Yeah, that's his lab. While he's getting it ready, that's his lab that he works in all the time.
Yeah, I should say the.
Is that his lab?
Yeah.
Everything in the background here is about 60 or 70 computers of various types that we use for deep space communication protocol networking, networking protocol research and development. Briefly, a long time ago I came along, I was a system engineer after leaving Lockheed, coming to JPL, worked on the Mars Observer program, spacecraft avionics system engineer for Mars Observer. Then I flew it I got to be the deputy spacecraft team chief for operations. We flew it to Mars where it promptly blew up. It's a whole other story. Very unfortunate. We took the spare parts and everything else and built the next spacecraft, which was Mars Global Surveyor. That was a very successful orbiter around Mars, and did a lot of pioneering close-up photography of the surface. And then after that, Mars, you'll see all the Mars programs later. But at one point in that evolution of my career, I discovered that computer greenies didn't know anything about radio. And the radio guys, the soldering iron burns on their knuckles, didn't know anything about computers. And they were constantly fighting over how to make internet-like protocols work over space links, over radio links. And so I got some funding to put together a lab where we could bring both sides, if you will, in and try things with real computers, real computer protocols going through real RF links. And the rest is history, as they say. So let's get on with this. I'm sharing this screen, so if I go to full display, place setting.
Looks good.
Do you think that okay?
Yeah.
Good. JPL. That's beautiful.
Okay, so anyway, this is where JPL is. It's in the foothills of the local mountains here north of Los Angeles, kind of in between Pasadena and Burbank or La Cañada. Very nice. I love living in California because, as you can see in this picture, usually that's where we have snow. It's up on the mountains where snow should be. You can just sit there and admire it without having to shovel it. JPL started out work on that. At JPL, I said Caltech briefly. JPL is a federally funded research and development facility And unlike other NASA centers, we're not civil servants, we're all Caltech staff. So, which has a lot of advantages as far as getting educational discounts on software, for instance. But so it's nice to be associated with the university, Caltech, because you've got an endless supply of genius, brilliant summer student geeks that come in here. And, lots of good work for me. I really enjoy working with the kids. They're young, enthusiastic, they're not burned out, they're not jaded, they're not cynical, and they're completely enthralled by all of this stuff that I've been working on for the last 30 years. Well, anyway, somewhere in the 1936 vintage, a bunch of guys at Caltech, one of which was the head of a Satan worship cult. It's really bizarre. They were experimenting with rocket engines in Caltech after explosions on the campus. They were booted off and told to go up to the Arroyo, which is where JPL is located now. And they went ahead and did all their initial rocket experiments up here, where at the time it was uninhabited. It was pretty safe. In 1941, the war, they started using the rocket technology to come up with jet-assisted takeoff technology to help airplanes take off from short field takeoffs. And they finally established it as the Jet Propulsion Lab in 1943. Then the Army came along and said, hey, those JATO things are so cool, why don't we try building a rocket? And so in 1945, they built the WAC Corporal, and followed by the sergeant. I'm not sure if this, let me see if this little video plays at all. So anyway, sometimes things go better than other times. They went from the corporal to the sergeant missile, and then about 1957, and I still remember as a kid, I'm old enough to remember this. I remember my dad taking me out to the front lawn to look up to see Sputnik go over from our house in North Hollywood. So of course Sputnik went up. Everybody's either lived through that or seen it in history books. We decided we had to do something to counter that, and so they got Theodore von Karman,
Werner von Braun right there.
Yep. It's William Pickering, Theodore von Karman, and Werner von Braun. We get the Explorer 1, which was the first U.S. satellite. And originally it was going to be Goddard was going to send up something that Goddard himself had developed with the Army. And it didn't work so well, apparently. And we had the Navy had this backup program, which became Explorer 1. So the JPL and the Navy and that illustrious crew were the first people to get a U.S. satellite up.
What's an Army missile, not Navy?
NASA was created.
There you go.
And at some point, the university, Caltech, decided, we didn't really want to be involved with military work so much as science work, because that, of course, is the foundation of Caltech. So we completely got away from the WAC Corporal and the rocketry and that sort of thing, and started building spacecraft. So the first one was the Mariner 2, and then Ranger missions to the Moon, Surveyor to Mars. Going through this little quick. And then finally, in the mid-70s, they launched Viking, which is a $2 billion program, Viking 1 and 2, which were the first landers on Mars. And the interesting thing about that I've learned is that the science instruments they took to Mars on Viking to determine whether or not there was life on Mars brought back ambiguous results that to this day are still ambiguous, still being argued over by the science community. I thought it was kind of interesting. we shipped Voyager off in Voyager 1 and 2, and that, of course, was a terrific mission that did a grand tour of the entire solar system. I've got other pictures of Voyager at Saturn and Neptune and so forth. 86, it made it to Uranus, and 89, it made it to Neptune, and that's about the time I came on lab. They had a Planetary Society event at the Pasadena Center, a big convention center in town, and I was a member of the Planetary Society, and they asked for volunteers, so I took a week off work at Lockheed and volunteered to go help them out with their public event. And the nice thing about that is in those days there wasn't any embargo of scientific data, and so the public got to see the data real time as it streamed down from Neptune and built up a scan line at a time on the screen. And so the whole place was, over a couple thousand people in auditoriums and wandering around this big convention center. Would just stop and freeze when the next picture of Neptune would come up. And you'd hold your breath, and you'd finally see features like almost like a great spot at Jupiter. Clouds build up. I still remember the gasps of astonishment in the audience. And that's when I met somebody from JPL who convinced me to turn in my application, and that's how I ended up coming to JPL. So I've got a.
And Lee, be sure and play that video. Be sure and play that video on Neptune when you get a chance too.
Which video was that?
The one where Neptune, the bands move.
I don't remember if that was on this.
Maybe it wasn't on this one.
He has a video of Neptune.
Yeah, it's really cool.
Okay, these are pictures of Saturn from Voyager. There's audio, but I turned it off because it kind of disrupts the. Okay, how about you can hear me now?
Yeah,
Yes.
We got you.
Okay. And just in order, they had the infrared astronomical satellite, IRIS, and that was the first one, I think. And then there was COBE, which was Cosmic Background Radiation Explorer. We were involved in that. Let's keep going past Neptune. Magellan, we got a mapping mission to Venus. The Hubble Space Telescope launched with a JPL-built camera, and of course, you know the sad story about the telescope had a problem with the way the lens was ground, or I can't remember if it was out of focus, if it was an astigmatism, but anyway, it was really disappointing when they started getting the first Hubble pictures done. It looked like it was going to be a complete loss. Fortunately, JPL built the Wide Field Planetary camera and was able to correct the optics on Hubble, and they had a remarkable space shuttle mission that went up to Hubble. It was the farthest space shuttle had ever been in the highest inclination orbit. It was a very hazardous mission from that standpoint. But they, as you all know, successfully replaced the WebPic, so we got the wonderful, years and years of wonderful Hubble pictures. We shipped Galileo off to Jupiter. And got the first close-up pictures of Jupiter. The antenna here, it's kind of interesting. The spacecraft was supposed to launch on one of the space shuttles, and then we lost Challenger. And so they couldn't launch the mission right away. They trucked it back or flew it back to California, figured out what to do, figured out a whole new fairing package and everything to launch it on an Atlas. I think it was an Atlas. And in the process, the chemical or the dry lubricant that lubricated the spars for the umbrella-like deep space high gain antenna apparently fell out. So when they got to Jupiter and went to deploy the antenna, it wouldn't open, and it only opened about that far. And of course, that was going to be a horrible loss of data for the scientists. And up to this point, the science community would not let us compress data because they said, you know, compressing data is evil because you're gonna lose data. Because nobody had really figured out very good lossless compression algorithms. So, forced by the circumstances with Galileo, the engineers were allowed to come up with some new compression algorithms that indeed were lossless and enabled them to get 90 or 95% of the originally planned data from Galileo over the low gain antenna. So that was a tremendous success, even though we had a problem with the spacecraft. Mars Pathfinder and Sojourner landed. Next, Pathfinder was a little guy about the size of a skateboard that did the proof of concept for this silly method of dropping the thing into the atmosphere, using a rocket to slow it down, and then releasing a thing encased in a bunch of balloons, a bunch of airplanes.
But it worked.
Yeah, it's amazing that it worked. And so here's a picture from the landing pedal, the landing platform thing, where Sojourner actually drove off this and ran over to the nearest rock, drilled a hole in it, everybody cheered. You see how big this thing is. It's about, I don't know, 18 inches, 24 inches long.
18 inches, yeah.
So, since that worked, they were able to go ahead and scale that up for Mars Spirit and Opportunity, the two Mars exploration rovers. They were supposed to last for 90 days, and they lasted for years. It was just amazing how well they survived. And then used that same balloon type landing approach. Genesis, let's see. Genesis was an interesting mission. So Genesis was, the idea of Genesis was to have a bunch of little plates that had aerogel in them that would go out into space and put these things out like tennis rackets into the solar wind and try to capture particles and get samples of what actually the solar wind consisted of outside of the Earth's magnetic field. And the idea was that it would collect all these samples, it would come back, it would hit the atmosphere, slow down, and at the appropriate moment after decelerating enough, deploy a parachute, and then the parachute would allow the spacecraft to gently come down in the atmosphere, and they had a helicopter with a James Bond-like hook that was going to go by and hook the parachute and recover the spacecraft and bring it back. So, as it turns out, somebody mounted the accelerometer backwards, so it never sensed the deceleration, and so it never deployed the parachute. And we were watching, I was watching in a conference room, and they had a camera, a telescope, so they could see the spacecraft enter the atmosphere and slow down, and all you could see was, imagine in your mind a blue sky, dark at first, getting lighter and lighter as the camera panned down, and seeing nothing else except for the spacecraft kind of floating along. And someone said, well, the parachute should have deployed by now, and a couple seconds later, the ground just comes up from the bottom of the screen and swamp. I'm laughing about it because at the time it wasn't very funny, even though we all did kind of laugh and make jokes about how the Roadrunner cartoon would have the parachute come out now. So they went out and they dug the thing out of the desert, and they ended up, it was packaged so well, they ended up getting about 85% of all the samples pristine and with no problem. So it was another success by sheer dumb luck. Spirit and Opportunity, won't go into those much. I worked on the UHF antenna and the UHF radio on this. These things are about the size of go-karts, something like that. They're and they're solar powered. And the interesting story about them is And solar panels were losing power little by little as we went along. And it was because dust was accumulating on top of the solar panels. And nobody had thought about that or figured out how to blow dust off the top of the thing. And one day, all of a sudden, the power just jumped up in a big leap, and everybody rejoiced. What the heck was that all about? Well, they discovered a dust devil, just like a little dry miniature tornado kind of thing. The dust devil had gone by and blown off the dust. And so from that point on, the standing joke in the shared opportunity team to keep an eye on the panoramic camera and look for dust devils and try to drive over next to one if the solar panels dusted off. So finally here we got 2005 Deep Impact. That's where we took an impactor and a spacecraft. The impactor was released and flew into the comet and caused a huge amount of debris to boil off the surface of the comet so that the instruments on the carrier could analyze and get more mass spectrometer data on what comets were made of. Stardust was similar to Genesis program where they flew through the tail of a comet. We get some cometary dust particle samples to more, find out more about what comets are made of. And then the last Mars thing I'll go through in this slide deck is the Phoenix Mars lander. That was one where they took some spare parts and they grabbed the one and only UHF radio I had left in my lab and stuck it on Phoenix, landed it on the South Pole of Mars. Nobody'd been to the South Pole yet. Everybody'd been to equatorial regions, Viking and the Curiosity, and even some of the Russian missions all went to the mid-latitudes. So we landed Phoenix on the South Pole, and near where the ice caps were. And as you can see on the right, they used a little shovel scoop thing and started scooping up some of the soil, and they discovered water ice underneath the soil. So that was one of the first indications that there is frozen ice on Mars. And the reason why that's important is if you've got water ice and if you can mine it, if it's not too terribly cold, you can take the water ice and use solar power to break it down into oxygen and hydrogen. And of course, oxygen is for breathing, and the hydrogen, you can use the oxygen and hydrogen to make up your own fuel. And so the thought for future Mars missions, human Mars missions, would be to send up robotic missions first to land and start creating oxygen and hydrogen. So when the astronauts get there, they've got oxygen to breathe and they've got components to make fuel for the return trip. That sounds pretty science fiction-y, but that's the line of thinking people are going down at the moment. So I think that I've got better slides. We did Mars Odyssey, another orbiter, Mars Reconnaissance Orbiter still up there, another orbiter, and of course we did Curiosity, and then the follow-on to Curiosity this summer. JPL also does a bunch of Earth observing missions, RapidSat, Grace, CloudSat, looking at the mission to planet Earth. Mostly those are managed by folks out of Goddard, but JPL has either built the spacecraft or built the instruments, or in some cases operated the spacecraft like SMAP. We had Cassini, which we'll talk about, and Geno's up there now. Don went to the Vespa, and then Voyager 1 and 2 are still out there. Voyager 2 just left the heliopause, so it's out in the interstellar space now, which is a very exciting thing. A friend of mine, who I kind of mentored this young lady when she was in college, and she ended up coming to Caltech, getting her PhD from Ed Stone, or Ed Stone's the chief scientist for the Voyager mission. And she ended up being this grad student and looking through Voyager data, and she discovered some issues with, and some instruments on Voyager, particles and fields instruments that were showing anisotropic cosmic background radiation. And of course the models are that cosmic background radiation should be equal from all different directions. And as Voyager rotated in its particles and fields instruments rotated through the picking up cosmic background radiation, there were asymmetries that they were noticing in a certain plane, and it was driving the scientists crazy for about the last 30 years. And she did some modeling and discovered that one of the components in one of the instruments was mounted 180 degrees backwards. And when she corrected the data for that hypothesis, it made all the data come out correctly and got rid of the mysterious anisotropy of the cosmic background. It was pretty exciting. So, are there any questions while I move on to the next?
So what is Juno finding on Jupiter?
I went to, I called up Julie Webster, who's the program manager on Juno. I worked with her for a long time. She was the program manager for Cassini when it did its final plunge. She's now the program manager for Juno. And I asked her if she had a slide deck I could show, and she was completely tied up at the time and said she'd get back to me, and I never got anything back from her. So, yeah, I gotta stop sharing apparently. Go back to PowerPoint. Yeah, I'm gonna have to defer on the Juno question until I hear back from Julie. Maybe that'd be a topic for another talk some other day.
Anything new on the Mars? There was a Mars quake recently, Lee, like Monday or Tuesday. A Mars quake. Did you hear about that?
I did hear something about that, but I didn't follow up on it.
Just a run.
You get any earthquakes in Pasadena?
Yeah, we have.
You get tremors all the time.
Yeah, we had a big one 10 years ago, and but it's the number of earthquakes as compared to the number of hurricanes, tornadoes, floods, humidity. That's why I live here instead of in Florida. And I already mentioned that I like to see the snow up on the hills, so I'll take the earthquakes. If you're prepared for earthquakes, if your house is bolted down, you might have a bunch of stuff falling off shelves. If you don't run outside a building when the earthquake starts, you get hit by a gargoyle or something. Earthquakes are pretty survivable and disrupt things. When you had the big Northridge earthquake where some freeway overpasses fell down, fortunately it was early in the morning and there wasn't much traffic, so I think a couple of people were killed. It disrupted the transportation infrastructure, and for about a day and a half it was you had to drive 5 miles to find a gas station, so it wasn't a huge earth-shattering event. I had fun, but okay, let's see, I've got to figure out how to stop. Oh, okay. I'm an operator error here because I keep trying to control the slides you're seeing with my laptop, but they're on another computer. Oh, go back to here. Go back to here. Share content. Okay, so, yeah, you see that okay?
Yes.
When I first started at JPL 30 years ago, I had my choice of working on the Mars programs or Cassini. And it was at the time Kraft Cassini was the dual program. And the interviewers told me that, well, you know, Mars, we're going to launch something to Mars every 2 years. And I was really amazed at the Cassini mission. But they explained it's going to take another 2 or 3 years to launch, and then it was going to be 7 years to get to Saturn. And then once we got to Saturn, you know, we did the prime mission for a number of years. And I was thinking, I don't want to spend the rest of my life on one spaceport. So I chose to work with the Mars program. And as it turned out, the Huygens probe, which is the probe that they sent into the atmosphere, was sent to Titan. I did get to work on that. So I did get some work on Cassini, and I knew a lot of people on the program, of course. But after the prime mission was over in 2008, they different seasons, equinox and solstice mission, they did a bunch of close approaches to the planet that they were afraid to do before because they didn't want to risk losing anything. And then finally, because of running out of maneuvering fuel, I finally had to cancel. I had to kill the mission in the grand finale in 2017, which was very sad, but it was an astonishing mission. They very, very complicated orbital planning because the thing would go out pretty far and then swoop in very, very close to the planet to get better observations. And they had various orbits that they put into place so they could kind of graze the rings and get some close-up data from the rings. And then the grand finale orbits, one of the interesting things about the grand finale orbits, if you notice in the blue there, they go between the planet and the rings, which is pretty astonishing. I'm still amazed at how accurately they can navigate something as small as spacecraft so far away. By going between the rings and the planet, they're able to, with radio science and very careful measurement of the Doppler, the radio frequencies, and the other instruments that they have in the spacecraft, they're able to get a lot better data on what the mass of the rings are and what the composition of the rings and the Saturn's internal structure. They've got magnetic, the gravity measurements with the radio science, the magnetic measurements with the magnetometer. They're able to look at the mass of the rings. They were able to address the age of the main rings. And it turns out they're somewhere between 10 million and 100 million years old. And so they're fairly recent additions to Saturn. And kind of went through my mind and said they talked about the rings being around the age of the dinosaurs, and you have to think back about the asteroid that hit the Earth and caused the KT layer and the dinosaur extinction event and everything, and wonder what in the heck was going on in the solar system back then. Caused no dinosaurs and a nice ring around Saturn. They were also able to do measurements of the ionosphere because they got into the ionosphere of Saturn before they went in. And of course, a lot of high resolution observations. They found some new strange moons, like this thing, named Pan. And to me, that's one of the fascinations about the solar system, even though, astronomy and the Hubble and the rest of the galaxy, and I'm in love with all that as well. But the fascinating thing about the solar system is if you look at pictures of the different moons, there are no two moons around any planet in the solar system that look alike. And not only do they look different, they look different in totally astonishing and surprising ways. This little guy's inside the rings in the Z-orbit Saturn, that shepherds the one of the little thing they call Daphnes. It actually makes waves in the rings that they were able to take pictures of. When we plunged through the gap, they got a lot of very close-up imagery and radar, text radar imagery that they took. I don't know if that animation's playing that well, but
it's doing pretty good.
Yeah, there we go.
About 5 frames a second, not bad.
Yeah, okay. You get the idea. So they were able to.
Let's count in 3.7.
Good data, which should show up next, was camera data. And as it goes along, this is what it's taking a picture of. So they got a lot of fairly high resolution data on the surface, or the tops of the clouds, if you will. From Saturn, they also made a point of taking a picture of everybody else they could take a picture of. So there's Mars from Saturn, there's Venus from Saturn, there's what Jupiter from Saturn looked like. I thought that was pretty amazing. That Jupiter was that big from Saturn. Uranus and Neptune, and they were able to get a picture of the Earth and the Moon, and a picture of Pluto.
Wow. That's pretty amazing.
Pretty good camera.
Yeah.
Much of this data is online at the JPL and also the NASA websites. Curious, just to know that's the wrong one. Okay.
Inside out.
So more pictures of the rings, and that is the last view of Earth. That's Earth from Saturn. And then with thermal infrared camera on the 5 micron range from the I forgot what V stands for, infrared measurement system. This is kind of what it looked like as it was coming in the atmosphere. And this is actually where it finally hit Saturn and burned up in the atmosphere. The last visible image rather is a nighttime view of Saturn, and you can see the sunlight reflected off Saturn's rings down here. And you see a lot of colorful pictures of these planets, but a lot of it's false color, so the real color is maybe not quite as spectacular. And that's that. Okay, this little video. See, that was all the Cassini slides that I had. The next thing is I'll show you just a quick video of a quick cartoon kind of animation of how I'll stop sharing and then share you'll see. Okay, so this little animation was called How to Get to Mars with Curiosity. So basically what you've got to do to get to Mars is you're going 13,000 miles an hour when you hit the atmosphere. You've got to slow down with the aeroshell, the back shell. You got to hit just the right angle. And as the shell slows the thing down, finally a supersonic parachute comes out, and radar altimeter measures where it is. It drops a rocket-powered platform that's holding the rover, and then the rover gets lowered down to the ground on a cable, and then the platform flies off so it doesn't create dust, and that's when you finally end up landing. There was another, I wish I could play better video. There was a pretty good, one of the problems is that I play the video, but the audio doesn't come through. We haven't figured out what's going on with that. Maybe next time, by next time we'll sort that out. But they call it the 7 minutes of terror, because the whole process of, from the time of hitting the top of the atmosphere to landing took about 7 minutes, and while I was doing that, we were basically out of communication with it, and so everybody's like holding their a little bit of radio communication, so they had some almost like Morse code, quick little cues that would be triggered when certain events happen. So the spacecraft team on the ground would know if things were proceeding. And when Curiosity landed, they also, Planetary Society also did a big event in Pasadena and had about 5,000 people from the public there watching. They had several thousand people on lab watching. It was broadcast around the world, and it was quite a astonishing moment for everyone to watch that thing land and to see the first picture from the first camera come back to Curiosity. Well, we got to hold our breath and do it all over again this summer with the follow-on. Curiosity, and I wish I had more slides on this, come to think of it now, but I didn't want this whole thing to just turn into an hour-long Mars talk. But Curiosity was nuclear powered with a radioisotope thermal generator that the heat of the plutonium causes thermocouples to create electricity, which has been used to charge the batteries.
Lee, did you guys invent that?
Sit around for several hours while the batteries charge up, and then they get enough of the charge, and then they go off and do their driving around and drilling holes in rocks and taking spectacular pictures. The follow-on that's launching this summer is going to have more chemistry experiments to try to detect precursors to life and complex organic molecules and that sort of thing.
We got a question from the audience here, Lee.
Yeah, sure.
Lee, did you guys at JPL invent those nuclear power plants, nuclear power packs?
Actually, the Department of Energy, DOE, is the sole proprietor of nuclear thermal power plants. They built them for Voyager. They built them for Juno, Cassini, and then they built the ones for Curiosity and for the next one. Yeah, it's very symbiotic relationship between NASA. We just buy them from the DOE.
Okay. Thank you.
So the next thing I will go through
I don't think everybody signed.
is, to stop that, I'm going to go back to PowerPoint.
I think 22. You sent somebody probably with the rust. Yeah.
Chad, is Chad on here? Chad. Oh yeah, but not Caitlin.
Right there.
Oh, Caitlin, yeah, I see her. How about
What's on his
how about Randy? Randy, did you sign it? I don't know who's missing. Somebody's missing on the sign-in sheet. Oh, okay. That's what it is.
Wait, I got you. You're in the wrong pen.
All right. Sorry.
So, who's that? So one of the things that was discovered by Cassini in Voyager.
It's really nice. I like that.
was that there are a lot of very, very interesting moons that we need to go look at.
Not a clue. City sign.
Okay, somehow PowerPoint just crashed. Let me start PowerPoint back up again. Thank you, Bill Hicks. And
Thank you.
4, 5, 6.
Share, and share that. Followed by, we'll spend
24.
slideshow. Certainly Morgan is a PhD biochemist from Caltech. And she and her team have been looking at, they're looking at how do you detect life, number one. Number two, what the heck does life look like at 70 degrees Kelvin, 70 degrees above absolute zero, very, very cold. And why would you worry about that sort of thing? Well, there's the discovery of a whole bunch of very interesting icy moons around Saturn and Jupiter. Okay, so this is from Morgan's slide package. He gave me that we did presentations about her work, and she, of course, asks the rhetorical question, what's an ocean world? Well, it turns out a lot of the moons we found have a metallic core and some sort of a rocky interior, and then above the rocky interior is a liquid ocean under a surface that's basically ice, which is a very fascinating thing. The planets, these moons, as they orbit around Neptune and Saturn, and there's a bunch of other moons, as they influence, they feel the gravitational influence of the other bodies. They actually undergo deformation and gravitational effects that can create heat and actually have warm cores and pretty astonishing physics. So we talk around Jupiter. We've got Europa, Ganymede, and Callisto are all icy ocean, ice-covered worlds that they think have a liquid ocean underneath. That's a good example of what I said earlier about all the moons are always look different, and no two are alike. Titan, which the exterior, the outside covering of Titan, or the surface of Titan, is methane atmosphere with lakes of liquid hydrocarbons. It's that cold, and it's very smoggy, not a very nice atmosphere. But even so, below the surface, and we've landed on the surface of Titan with the Huygens probe, they believe there's still an ocean world underneath the surface of Titan. And Enceladus also has definite ocean characteristics. And even Mimas, which is the Death Star,
That's so cool.
The one huge crater from a long time asteroid strike, a long time ago asteroid strike, suspected to be an ocean world. And then you go out to Neptune, the moon Triton is an ocean world. And now they're thinking that Pluto's also got liquid water, liquid ocean underneath the surface. So, go to Saturn. One of the things Cassini noticed is that Enceladus here, that this water jet's coming out of it. It's just blowing right off the surface of this moon. Some astonishing pictures, and ultimately in one of in the final days of the mission, they flew through those plumes to measure what the plumes are made of. And you can see a close-up picture of Enceladus here with these rills with this kind of a blue color, and they think those are actually crustal splits that go down into where the ocean is. They've got thermal imaging data. There's another great picture of Enceladus from Cassini showing the jets of material coming out of the moon, out of those rifts or riddles, wherever they are. And some infrared data. They can see there's some warmer spots and some colder spots. And so it's definitely active. It's definitely warm enough. They think that there are hydrothermal vents that are greater than 90 degrees Celsius underneath, and with the active jets in the south, in the polar regions there. Wrong one. There we go. And there's another infrared picture that they got of the South Pole. You can see the they call them tiger stripes. So we're really interested in sending a mission to Enceladus someday to take a look, see what's going on, see if there might be life underneath. Because when they flew through the plumes, they found that the plume composition was not only had water, carbon dioxide, methane,
ammonia, hydrogen.
I just noticed Morgan was excited. Some heavier hydrocarbons and some organic materials, and a mass flux of 200 kilograms per second. So that's quite a bit of mass being shot out of that moon. Would be nice to go explore someday. I've got a bunch of your slides that went on to explain the organic chemistry of why all these things are important to life. Because I barely made it through chemistry and college myself. But these are some of the new data that have just been in the last couple of years from the Cassini's last mission time. This was 2018 when this paper was written in Nature magazine. The mass spectrometer shows the peaks from the cations of benzene and various sodium clusters, that sort of thing. And apparently, as Enceladus goes around Saturn, it's actually adding an extra ring called the E ring, which is fairly faint. Probably couldn't see it with the telescopes, but it's there, and it made silicon dioxide, made those vents. And then, of course, hydrothermal vents. You all know about hydrothermal vents on Earth, where it's a totally unlikely place for life to exist, because there's no sunlight. It's got enormous pressures and huge temperatures, and yet there's all sorts of life down there. And there's a great picture of Jupiter, and yeah, I wish the videos worked, because some of the videos that they took of Jupiter showing the swirls and the composition of the atmosphere, just remarkable. And I guess you had to talk about the hexagonal ring, the hexagonal shape on the top of these gas giants. It still blows me away. Well, there around Jupiter is Europa, gem of the Jovian system, and it's Morgan's model of what they think Europa looks like from all the data that we've got. So they're starting a mission now. It's a joint mission with the European Space Agency called Europa Clipper. And Europa Clipper is going to go there and do an exploration mission to Europa. And it's actually going to land a lander on the surface of Europa. And the lander's got a little scoop. We're going to reprise the Mars Phoenix mission kind of in a way where we're going to try to scoop up some of the surface. They've got chemistry apparatus here. I don't even see my cursor moving, but there's like a little box here, and in the animation it shows it scoops up some surface material on the arm, goes over and it drops it into this trough. And then it gets pulled inside the spacecraft, and then there's some chemical apparatus inside to do spectrometry and other chemistry experiments on it to get a better handle on what the surface is made of. Saturn has got Titan. We first went to Titan with the Huygens probe, but there's a lot of similarities between Titan and what we see on the Earth. You can see clouds, you can see river channels on Titan that look very much like satellite pictures of the river channels on Earth. You can see lakes and seas, and the one on the left on Titan is somewhat on the same scale as the Great Lakes on the right.
Yeah.
Click first and then ask questions later. There's remnants of ridges that geologists call karst, and there's very similar structures on the Earth in Titan. There's dune fields, so Titan's got an awful lot of geological features that are very tantalizing. It's 96% nitrogen and 4% methane, and it's thicker than the Earth's atmosphere.
Methane, that doesn't sound very pleasing.
Organics, dunes. It's got a hydrologic cycle that rains liquid methane and has ethane lakes and methane clouds and drizzle. So it's pretty cold. Make all those gases liquid. And I suspect there's cryo volcanoes. Why I'm not a planetary scientist, I can't say the word cryo volcanoes.
That's okay. We can't either, Lee.
Just say cold volcanoes.
And you don't want to show this slide to your junior high school students because they'll want to make one for the science fair. So, infrared, some of the possible volcanoes. And so there's a mission that the APL is running, and we're working on a New Frontiers mission called Dragonfly, where they're actually going to drop a quadcopter down there. Have it land, and then it'll put up a tagging antenna that will probably talk to an orbiter and actually fly around and try to take data. That's the next thing. I forgot to tell you, but on the Mars 2020 mission, it's going to be the first quadcopter on Mars. It actually got a quadcopter mounted underneath, and after it lands, the quadcopter will drop down to the ground, the rover will drive off, and then the quadcopter will be treated as a proof of concept experiment. And it's amazing that you can make a helicopter-like device, or in an atmosphere that's a tenth of the Earth's atmosphere.
That must be nuclear powered as well. That tiny.
Yeah. Yes, that would be. And then the last slide I just snagged because I thought it was pretty neat. The exobiology, the exoplanet effort that the world's astronomy community has been working on with the fly planets around the stars. They've already found a number of potentially habitable exoplanets that are about the right size, gravity-wise, they're about the right distance, they're in the habitable zone, the right distance from the stars, so they're not too hot or not too cold. And this was just kind of an
Oh no!
Update later. Update later. Oh.
Is that them? No, it's a PC product.
I didn't hit my knee on that thing.
I can't call him and tell him we lost him.
He's just talking away, I'm sure.
So he knows we lost him because he sees us.
So they're running Apple over there, JPL?
Yeah, it looked like it was. Yeah.
That's Apple TV. That's Apple.
Are you sure? That's a full screen.
Can you click update later? Can you grab the mouse and click update later? No, it's not touchscreen.
I have been, I knew it wasn't me, right? No.
What George didn't tell you about those kids at astronomy in Richmond is he's over on the laptop working like crazy. And I'm just totally ignorant of what's going on. And one of these little guys about this tall walks up and taps the screen. Everything just fired right up. It was touch screen.
Yeah.
And he knew exactly where to go and what to do.
Like a smart board, but it was a touch screen. I was trying to work with the cursor and I wouldn't get what I wanted to do. Just touch the screen and it works. And several times I touched the screen by accident and it did something I didn't want it to do.
I think it's safe to stop the recording.
Yeah, I guess we'll stop the live.